Hello, welcome back. So we're on to part 2 of the University of Helsinki's massive open online course. In this section we're going to be looking at recurring problems and patterns to solve them, repeating functionality, can look at more loops, methods and divided the program into smaller parts or blocks of code, and then there's an end questionnaire as well. So hopefully before we start this section, you guys and girls have all got your 100% in your program exercises and quizzes. If not, please feel free to go back and watch some of the other videos to just find out where you may have missed a couple of points or two. So down here at the bottom we've got a list of exercises, and you can see I think there's about 40 odd, so it's a good amount for us to get cracking with. And the first one is looking at recurring problems and patterns to solve them. So let's have a look. So it starts you down here, which is a bit far down actually. We need to just scroll back up to the top. So our learning objectives today are to recognise that certain subproblems, such as reading inputs or calculations, recur in programs. You're aware of solution models to certain problems, and you practice combining solution patterns used in subproblems to solve broader ones. The same problems or subproblems reappear in programs time after time. Read input from the user, calculate the sum of values, and so forth. Let's look at a few problems and patterns for solving them. So first we're going to look at reading user input. The solution pattern for programming tasks involving reading user input is straightforward. If the program needs to read from the user, a scanner helper tool is created for the task. The scanner is created in the main method after the line public static void main. To use the scanner, it needs to be made available in the program through the statement import java.util.scanner, which comes before the class definition. So if we have a look down here, we've got our import here, and that comes before the public class. What I'm actually going to do is just open my NetBeans, and I just want to show you how we can write a scanner ourselves. So we can do scanner, and then we can give our scanner a name. So we can call it SC if you want. You can call it scan or scanner, whatever you want to call it. It doesn't matter. Call it input. It's absolutely fine. And we're going to say that is equal to new scanner. And then we're going to open and close parentheses. And then between the parentheses, we're going to write system.in. Okay, and on the end of the line, we're going to put our semicolon. And then we should get two errors. There we go. And what these errors are saying is that they're looking for this class scanner, but they can't find it. So we can click on the red underline and press Alt and Enter on our keyboard, and it will give us up a few different options that we can try in order to overcome this error. The top one is actually the one that we need, which is add import for java.util.scanner. But I'm just going to show you a couple of other ways that you can help resolve this error. So you can see here on the top right hand corner we've got a little red box. We've also got a red line. And then here we've got this light bulb with a red question mark in it. If we click on that, again we can click the add import for java.util.scanner, and that is another way that we can do it. Or if you're starting off your project and you know that you're going to be using user input, you can import it yourself, just like this, the good old-fashioned way, and type it in. Like that. Okay, so we'll just head back to the course here, and we will carry on. So I've already done this. I forgot to press play again on the recording. So the question is, what should a user give as an input for the program below? So it's 2 times something is equal to the value of 12. You know, so it's obviously 6. And then here we start to talk about calculating. We often need to calculate something in a program, such as an average or a sum. The solution pattern to solve such problems is as follows. Define the inputs required for the calculation and declare variables for them. Input refers to the values used in the calculation. You can typically identify the type of inputs from the problem description. Identify the operation needed and declare a variable for the result of the calculation. Perform the calculation using the inputs and assign the result to the variable that it was reserved for. The type of result can usually be identified from the problem description. Once the calculation is done, do something with its result. This can mean printing the result of a computation or, for example, using it to calculate an average by dividing it by the sum of its inputs. For example, the solution pattern for the problem create a program to calculate the sum of 2 integers is the following. So here we've got int first is equal to 1, int second is equal to 2, and then we've got the sum, which is where the answer will be stored, and sum is equal to the value of first plus second. And then we've got a printout here. A program that reads and calculates combines both of these patterns. One that calculates the product of two integers provided by the user looks like this. So here's their scanner, so that's ready for taking input. We've got our two integers, so first is equal to 1, second is equal to 2. And then here they're actually reassigning the value of first with a user input, and we're reassigning the value of second with another user input. And then here the answer is being stored in product, and then there's a system out which prints out the values and then the answer. In the above example, the program has been implemented so that the variables are declared first, after which values are read into them. Variable declaration and the reading of values into them can also be combined into one. So here we go. So the example that they had up above, they created the variable first and assigned it a value, and then took the user input. So if we just look here, we've got int first equals 1, and then the user input's taken here. So they've just combined it to make it perhaps a little shorter, a little more efficient. But it's the same process, and then it prints out. So write a program that reads an integer from the user and prints the square of the given integer, i.e. the number multiplied by itself. Okay, let's get cracking. Right, so first problem is that I haven't got any of my packages or my Java classes ready to go. So if I go to TMC and then download update exercises, I get a list of all of the second part, okay, and you can unselect or whichever you need to do. So just quickly download those and then get them open, and there we are, we're good to go. So the first one of part 2 is squared, and they already gave us a bit of a clue there. If you don't know how to square a number, it's the number multiplied by itself. Well, so we've already got our scanner, they've already done the import for us, so all we need to do is return user input by user input and then print out the answer. So we can have a system out, so let's just quickly double check and see. So it doesn't actually say anything, it doesn't even ask for a number, so let's try it without a prompt, because we know that we need to put it in there, and it's not like this is going to go into sort of production. So we can combine our integer and our scanner input into one, so we can say int input is equal to scanner dot next int. There we are. And then the next thing that we need to do is multiply the input by itself and print out the answer. So we can do this one of two ways. So we can do int answer is equal to input, and then we will multiply it by itself. Okay, and that's one way that we can do this. And then we can do our system out and just print out answer, and that's to do the job. There is another way that we could do it. So we can take out this section here, and do the formula or the mathematics inside the system out. Hopefully that should work. Let's have a look and see how we do. Perfect. So the first one of the second part passed first time. That's got to be off to a good start. So let's close that one down and head back here. So we'll just give that a refresh, make sure we've got the points. Remember, you can click down here to see different solutions as well. If you want to see how, if you did it a bit differently, if you want to see how someone else did it, that's fine. Straight on to our next exercise. So write a program that reads two integers from the user and prints the square root of the sum of these integers. The program does not need to work with negative numbers, so we don't need to put an if in there, so that's good. You can calculate the square root of an integer with the command math.squareroot like this. So int number is equal to 42, double square root is equal to math.squareroot, and then we're passing number. So we're passing this variable here, and then we can print out this variable into here. Okay, so here's their example. So let's give that a go. Okay, so let's give this a go. So we need two user inputs, so we're going to do int in1 is equal to scanner.next int, and then we can write that line out again, or you can hold Control and Shift on your keyboard and press up, and then just go back and change that 1 to a 2. So there we've got our two user inputs. And now what we need to do is multiply them together, or add them together, sorry, and then get the square root. So we're going to use a double, and we can call that square, and say that that is equal to math.square root, and then we're going to do in1 plus in2, and then, oh, forgot my semicolon on the end of the line, and then we're going to do a system out, and in that system out we're going to put the variable square. So let's give that a run and see how we get on. Excellent, another one passed. So let's OK that, close this down, and go back to the course. Give that a refresh. Excellent. So now we're looking at some conditional logic. So problems often contain some conditional logic. In these instances, we use conditional statements. A conditional statement starts with an if command, followed by an expression in parentheses. The expression evaluates to either true or false. If it evaluates true, the following block, delimited by curly brackets, gets executed. So here, even though it's saying the value is greater than 5, if value is greater than 5, it's either true in that it is greater than 5, or it's false and it's not. So if it's true, it will run this first block of code, and if it's false, it will run either the next else if or the next else. Okay? So a program that prints OK if the value of the variable is greater than 42, and otherwise prints not OK, looks like this. So here we've got our initial value, which has been set to 15. If the value is greater than 42, prints OK, and else not OK. I'm sure we've already done conditional statements. I thought we did them in part 1. But there you go. You can also chain together multiple conditions. In such a case, the problem takes the form if A, then B, else C, then D, else E, then F, otherwise G. The chain consists of an if statement followed by an else if statement, each containing its own expression and a block. So with quite a lot of statements, you might see an initial else with a value here, and then maybe an else down here with no value and just the open and close curly braces. But sometimes you want to evaluate more than one function, and that's where the else if comes in, because you can add more functionality or more conditionals to it. So if it doesn't meet A, proceed on to B. If it doesn't meet B, proceed to C, and you can go as many as you want. Okay. The quiz below uses system.out.print for printing. It works exactly like a system.out.println, but it does not add a line break to the end of the output. What does the program below print? So we've got if number greater than 10, system.out.print hello, else if, okay. Okie dokie, so int number is equal to 12, if number is greater than 10, print hello, so I'm going to go for hello. There we go, excellent. So because number meets this condition first, so for example if this was 11, because it met this condition first, it would always stop at this first block, so it always tries to find the first condition that it can evaluate true against, so it would never run more than one statement. Okay, so conditional logic can be combined with other patterns used for problem solving. Let's look into a problem. Read two integers from the user. If the sum of the integers is over 100, print too much. If the sum is less than 0, print too little. Otherwise, print OK. The program below combines reading, calculating, and conditional functionality. Okay, so although the program looks a lot longer, it obviously is, but it's still stuff that we've already looked at. So here we've got our scanner, so that's absolutely fine, we're very familiar with that. Here we've got int first is equal to integer.value of reader.next line, and we sort of used our cheats way for that. Instead of doing that, we used next int, which is a great way to save a few keystrokes. We're saving the value of first and second in sum, and then we're running an if statement on this value here. Okay. So we are going to work with an absolute, so maths absolute function. Write a program that reads an integer from the user. If the number is less than 0, the program prints the given integer multiplied by -1. In all other cases, the program prints the number itself. A few examples of how the program is expected to function are shown below. So if we get -3, we get 3, 2 is 2, -5 is 5. Okay. So other than the fact that the title is absolute value, it hasn't actually made reference to maths.abs. So I won't write it with the maths.abs. If you're wondering what that is, it's just another, there we go, maths.abs. It's just another method in Java, so it just gives you the absolute value. Okay. So there we go, I'll close that. If you're interested, I'll put the link in as well, so you can have a look at that. And interestingly, Geeks for Geeks is a really, really good website, one that I use quite regularly. There are quite a few, actually, Java tutorial pages that I use quite frequently, and I can put all of those in the links as well, because they're a really good resource to know about and to sort of trust, if that makes sense, because you know it's reliable information. Okay, so we need to do this. Right, let's go. So back here, so we've got our absolute value. Default package, there we go. Okay, so we haven't got any prompts, nothing that I need to copy. So let's get cracking. So the first thing we're going to need is, oh, we don't even need a system out, do we? No, okay, cool. So we can just take an integer and call it in, so for input or integer, and say that that is equal to scanner.next, next int. So remember, you can use the value of if you want the longer version, but I prefer less keystrokes. And then what we're going to do is use an if statement. So let's say if in is less than 0, and we're going to run this first block of code, and the first block is going to be in times itself, or times 1, sorry. So we can try multiply equals 1. That should, oh no, hang on, it'll be -1, won't it? Cool, excellent. So basically what that means is that we are updating the value of in with itself times by 1. And it's just a bit of a shorter way of doing it. We can of course do it a different way. So we could say int ans for answer, and then we could say, oopsie. So we can say ans is equal to in times -1, and that's exactly the same thing. So, and the other option is else, and then inside there it just prints the answer. So we can just do, well, sorry, the input. So we can do systemout.print in. Okay. So let's give that a run, see how we do. Silly me, I forgot to put the system out in. There we go. Let's give that a run. Oh, I've got the first two right as well. I feel like I've tarnished my coding afternoon. Perfect, so we've got that passed. Just to show you the other way, the one that I did show you before, if we do in times equals -1, change that to in, and then give that a run, we should get the same result. Excellent, so that's passed as well. And I think that we can make it a little bit more efficient and reduce it down by one more line. So if we take this, we should be able to get the same answer doing that as well. So let's give that a run. And there we go, that's passed too. And I think it looks quite cool there. It looks more impressive, I think, but that's just me. So let's give that a close. Head back to the course, give it a refresh, and see what's next. So write a program that reads 2 integers from the user. If the first number is greater than the second, the program prints first is greater than the second. But presume, oh yeah, okay, so we need the numbers, so first is greater than second. If the number is less than the second, the program prints first is smaller than second. Otherwise, the program prints first is equal to second. The first and second should always be replaced with the actual numbers where provided by the user. So again, we're not being prompted for any sort of user input, so we can just get straight onto it. We don't need to write a system out. So let's head back to our NetBeans and open up comparing numbers. Okay, so we are going to need at least 2 integers. So we can say int in1 is equal to scanner dot next int. I had to think about that. And remember, you don't have to write this out again. You can press Control Shift and up on your keyboard, and then just edit it, and it saves you a few keystrokes. And I think that should be all we need. And now we need the if statement. So what we're going to say is if in1 is greater than in2, and then print out the first option. If it's the other way around, print out the other option. And if they're both equal, then it will be a default else. That'll make more sense when I write it out. So if in1 is greater than in2, oops, I don't know why, I always get my less than and greater than mixed up. And then we need to print, what do we need to print? I can't remember. 8 is greater than 4. Oh, and we need the full stop as well. I'm going to pinch that. So we can do our S out, and then what we're going to do, so we're going to need a bit of concatenation as well. Remember, that's where we use the plus to add a few bits together. So I'm going to put a space in here, and then we're going to say in1 plus is greater than, so here we'll get rid of that number 4 and that full stop. We'll put a plus on, and then in2. Now we need to add a plus, double quotes, and a full stop as well, because remember there was the full stop on the end. So that should evaluate to how we want it to. And now we need an else if for our second condition. So else if in2 is greater than in1. Ooh. And we can copy this, but you know what, I'm not going to, because it's good practice. So this time we would say in2 plus is greater than, oh hang on, did it say less than? Oh, it's smaller than. Is smaller than plus in2. Right, so I'm going to need to change my formula around as well, aren't I? I'm meant to be making this less confusing for you, sorry guys. Okay, and then the last thing that we need to do is our else, because there's only really 3 options. It either is greater, it's either smaller, or it's equal. There's no real sort of other way around it. So we can say system out, and then was it they are both equal, or 1 is equal to 1. I'm just going to copy that. Okay, so we're going to do in1 plus, don't forget to put your spaces in as well, between your double quote and the first letter, and the last letter and the double quote too. And then plus in2, and then we need plus, and then a full stop. So let's give that a run and see how we do. Fantastic. Excellent, so we passed that. Let's give that a OK. Close this down. Oh, there we are, and let's see what's next. Give that a refresh. Lovely. Wow, okay, so we've finished the first section already. That's great, gosh, we whizzed through that. So next is repeating functionality, so I will get that recorded for you in the next couple of days, and hopefully get back to releasing a couple of videos a week. But as always, thank you very much for watching. If you do have any questions or comments or queries, please feel free to put them in the comments below. But failing that, I will certainly see you next time, and happy coding.